Okay, now let us find the 8-point DFT of a given sequence using Radix2 decimation in time fast Fourier transform algorithm method. The steps of each computation stages are described in my previous videos, and now let us find the number of stages required for computation. Okay, we have studied in my previous videos that we had to express the DFT using this equation. Okay, as we are dealing with 8-point DFT, n is equal to 8 here. Okay, now 2 raised to m should be equal to 8. Now we know that 8 is equal to 2 raised to 3. Then m, therefore m will be equal to, we can equate the power. Okay, m will be equal to 3, where m is the total number of computational stages required. Okay, equal to number of stages. Okay, hence we can conclude that in order to solve this problem we need to make use of 3 computational stages. Now let us start from the first stage of computation. I am going to write down the equation for x of n as per the question, as per our question, that is given that x of n is equal to it, that is given in our question. What does it mean? Here 2 is equal to x of 0. Okay, this one is equal to x of 1, x of 2, and this 2 represents x of 3, this one x of 4, this one x of 5, x of 6, and finally this is x of 7. Okay, right. Now let us start the first stage of computation. Here it should be noted that we have to enter the inputs. That means we have to enter x of n not in normal order but in the bit reversed order. That is explained in my previous video in detailed. Now we have to enter the given signal x of n in the bit reversed order. I'm not going to explain deeper about that because that we have discussed in our previous video, and the link for that video will be available in the description box. Okay, now let us start. Okay, here this is the x of n in the normal order. Okay, normal order in the sense as per the given question itself. Here x of 0, x of 1, etc. x of 7 is written here, so we have to complete it. Just write it down here, and finally this is equal to 1. Now here we have to enter the bit reversed sequence. Okay, this is the bit reversed order, x0, then x of 4, not x of 2. That is in the normal order. Bit reversed order, this is of the form x of 0, x of 4, x of 2, x of 6, etc. So and so. That is explained in my previous video under the topic the first stage of computation in Radix2 DIT FFT. Okay, now let us complete this one. What is x of 0? X of 0 is equal to 2. Okay, then next x of 4. What is x of 4? X of 4 is equal to 1. Then what about x of 2? X of 2 is equal to 2. Then x of 6, that is equal to 1. X of 1, x of 1 is equal to 2. And x of 5 is 1. And x of 3, x of 3 is equal to 2. And finally x of 7, that is equal to 1. Okay, right. Now we have to draw the butterfly diagram as per this order. Okay, of drawing the butterfly diagram for the first stage of computation is discussed in detail in my previous video, so I'm not going to explain more deeper about that. Just going to draw the flow diagram, and I will be back to you after finishing that. Now I have completed the butterfly diagram. Here we entered the values in the bit reversed order, which is obtained here. Okay, x of 0, 4, 2, 4, and so on. Now we have to find the output after the first stage of computation here. Okay, here we have 2 plus 4 into w2 raised to 0. Now we need to know the value of w2 raised to 0, so let us try to find that before proceeding. Basically w p raised to r is defined by e raised to minus j 2 pi r by p. Okay, right, this is the basic equation. Here in our case that is equal to w2 raised to 0. w2 raised to 0 implies that p is equal to 2 here. And what about the r is equal to 0. So let us substitute in this equation. Then w p raised to w2 raised to 0 will be equal to e raised to minus j 2 pi r. What is r here? R is equal to 0. Okay, the equivalent to this one, into 0 divided by p. What is p here? That is equal to 2. That is e raised to 0, that is equal to 1. So we can conclude that w2 raised to 0 is equal to 1 itself. So let us put the value of w2 raised to 0 over here, equal to 1 itself. So we don't need to multiply with the w2 raised to 0 while writing the equation here, because w2 raised to 0 is equal to 1. Okay, clear? We proved here. Now let us find the values here. Here we have 2 into 1 into 1, it is equal to 2. And here we have one more connection. Signal is coming from 1 in this one into this phase factor or Tidal factor. 1 into 1 becomes 1. Here both are added together to get 3. Now here we have 2 into 1 into 1, 2 itself. Okay, now 1 into this one becomes 1 here, but again it is multiplying with minus 1, that becomes minus 1, that is equal to 1. This concept is also described under that topic, first stage of computation. Just please refer through that video if you do not get the concept. Just refer through that video, that's all. Now here we have 2 into 1 into 1, that is equal to 2 itself, plus 1 into 1 into 1, that is equal to 3. Here we have 2 into 1 into 1 is equal to 2, plus 1 into 1 into minus 1 become minus 1. 2 minus 1 is equal to 1. And here also 2 into 2 plus 1 equal to 3, and here also we have 2 plus into this one become minus 1, is equal to minus 1 everywhere. Here we have 2 plus 1 is equal to 3, and here also we have 2 minus 1 become 1 itself. And now the output of the first stage is equal to 3 1 3 1 3 1 3 1 3 1. Okay, now the first step is over. Now let us pass through the second stage of computation, in which this will be the input to the second stage of. Okay, now let us go through the second computational stage, in which the input will be the output of this computation stage. Okay, this will act as the input to the second stage of computation. Here we are going through the second stage. Now I am going to draw the butterfly diagram. Here also I am not going to explain more deeper about the concept, as we have discussed about that in my previous video, and the link will be given in the description box. So please refer through that. I will be back to you after finishing the butterfly diagram. Okay, here is the butterfly diagram, and in which I have shown all the connections and gain in each flow lines. Here it should be noted that in the bottom two lines, here the gain is -1 and here also -1, and in the next four line also, the last in the last two lines the gain is -1. Okay, here and here. Now let us enter the inputs. What is the input here we are using? Input will be the output of our first stage of computation. Okay, this is the output we are getting after the first stage of computation. These things are going to be written over here: 3, then 1, and again 3, 1, 3, 1, 3, and 1. These are the inputs from the first stage. Okay. Now, what is here? Here we have to enter the phase factor or twiddle factor. In the second stage of computation, that will be W4 raised to 0 here and W4 raised to 1 here. And here also we have W4 raised to 0, and here we should have W raised to 1. Then we have to find the value of W4 raised to 0. As we have discussed, WP raised to R is equal to E raised to minus J 2 pi R by P. Okay, now in this case P, what is P? P is equal to 4. In our case P is equal to 4. Okay, this is W4 raised to 0 is equivalent to WP raised to R. Then of course P will be 4 and R will be 0, and R will be 0. Then what is the value of this one? E raised to minus J 2 pi into 0 by 4. Of course that is equal to 1. And what about the value of W4 raised to 1? Let us evaluate the value of W4 raised to 1. Okay, W4 raised to 1. Let us find that also. W4 raised to 1. We know that WP raised to R is equal to E raised to minus J 2 pi R by P. Okay, right. Here this is equivalent to W. Here P is equal to 4. W4 raised to 1 is equivalent to WP raised to R. Now P is equal to 4, and what about R? R is equal to 1, and R is equal to 1. Now let us substitute for R and P here. That is equal to J 2 pi. What is R? R is equal to 1 divided by what is P? P is equal to 4. So this one is equal to raised to minus J. Raised to minus J. This 2 and 4 can be reduced. Therefore, what we are getting is J pi by 2. Now let us find the value of E raised to minus J pi by 2. By Euler's identity, that is equal to cos pi by 2 minus J sin pi by 2. And the value we are getting, we know that cos pi by 2 is equal to 0 and J sin pi by 2 is equal to minus 1. So what we are getting is W4 raised to 1 is equal to 0. This one equal to 0 minus J. Okay, as sin pi by 2 is equal to 1. So W4 raised to 1 is equal to minus J. Okay, right. Now let us write W4 raised to 1 is equal to W4 raised to 1 is equal to what we obtained is minus j. So let us replace all W4 raised to 0 with 1. This one equal to 1. Here is 1. And what about W4 raised to 1? That is minus j. This is equal to minus j, and here also equal to minus j. Now let us complete the output equations. Here we have 3 plus 3 into 1 into 1. Okay, plus next signal is coming from 3. 3 into 1, here w raised to 4, so 1 itself. Okay, that is equal to 3 plus 3 becomes 6. And here we have 1 into 1 into 1 plus, just isolate this one. Okay, and next signal is coming from 1 into minus j. Okay, 1 plus minus j, that is equal to 1 minus j here. Okay, right. Now here we have 3 plus 3 into 1 into minus 1 is also there. So that is going to be minus 1 is equal to 0. And here we have 1 plus another connection is coming from 1 into minus j. So minus j again into minus 1 here. So that is going to be 1 minus into minus become positive. So 1 plus j itself. Okay, right. And here we have 3 plus another connection is coming from 3 into 1. That is 6. Here we have 1 plus 1 into minus j, that is equal to minus j, is equal to 1 minus j. Now here we have 3 plus another connection is from 3 into 1 into minus 1 here. Therefore we are getting minus 3. 3 into 1 into minus 1. Okay, minus 3. Here we have 0, and finally here we have 1 plus 1 into minus j, that is equal to minus j here. Again, when multiplying with minus 1, then minus 1 minus into minus become positive, so 1 plus j itself. Now the second stage of computation is over, and the output of this second stage of computation is going to be the input of the third stage of computation. Okay, now let us go through the third stage of computation. Here the inputs signals input to this section are the output from the second stage of computation. Okay, and I'm not going to discuss more detailed about how to draw the signal flow graph of third stage of computation, which is discussed in my previous video, and the link will be available in the description box. So I will be back to you after finishing the butterfly diagram. Here we have the butterfly diagram, in which the twiddle factor or phase factor is W8 raised to 0, W8 raised to 1, W8 raised to 2, and W8 raised to 3. Now let us enter the input lines. These are the outputs of the second stage of computation. I'm going to write the result of our second stage. Okay. Here it is 0, then 1 plus j, followed by 6, 1 minus j, 0, and finally 1 plus j. These are the results of previous stage. Okay, right. Now in order to obtain the output equation, we need to know the values of W8 raised to 0, W8 raised to 1 up to W8 raised to 3. So let us first evaluate the values of these phase factors. Okay, we know that W P raised to R is equal to E raised to minus J 2 pi R by P. So when calculating W8 raised to 0, we know that P is equal to 8 here. And what about R? R is equal to 0. And R equal to 0. Therefore, W P raised to R, that is W P raised to R, become e raised to minus j 2 pi. What about R? R in this case is equal to 0 divided by P. P in our case is equal to 8. E raised to 0, that is equal to 1. So let us put W8 raised to 0 is equal to 1 here. Okay, W8 raised to 0 is equal to 1. Now W8 raised to 1. In this case, P is equal to 8. And what about R? R is equal to 1. R is equal to 1. Therefore, W8 raised to 1 is equal to, in this equation, while putting in this equation, we are getting e raised to minus j 2 pi into R. R is equal to 1 divided by, what about P? P is equal to 8 here. So W8 raised to 1 is equal to, here we have e raised to minus j 2 and 8 can be reduced, hence I'm getting as e raised to minus j pi by 4, that is equal to cos pi by 4 minus j sin pi by 4 by Euler's identity. And the result here we are getting is, cos, we all know cos pi by 4 is equal to 1 by 2 minus j. What is sin pi by 2? That is also equal to 1 by 2. Hence we are getting the result as this one. So let us write the result W8 raised to 1 here. That is equal to 1 by root 2 minus j into 1 by root 2. Next, we have to calculate W8 raised to 2. Similarly, while putting in this equation, we will be getting e raised to minus j 2 pi. Here R is equal to 2 into 2 by P is equal to 8. So actually what I'm getting is e raised to minus j, this 4 and can be cancelled, so actually the remaining thing will be e raised to j pi by 2, that is equal to cos pi by 2 minus j sin pi by 2. Okay, that is equal to cos pi by 2 is equal to 0 minus j sin pi by 2 is equal to 1. Therefore W8 raised to 2 is equal to minus j. Okay, well then let us put the value of W8 raised to 2 is equal to minus j here. And finally the value of W8 raised to 3, W8 raised to 3, that is equal to e raised to minus j 2 pi into 3 by 8, that is equal to e raised to minus j. 2 and 8 can be reduced, therefore e raised to 3 pi by 4 will be getting. Okay, right, this is equal to cos 3 by 4 pi minus j sin 3 pi by 4 by Euler's identity, and the value we are getting is minus 1 by root 2 minus j 1 by root 2. Just put it in your calculator, then you will get the answer as minus 1 by root 2 minus j 1 by root 2. Okay, so let us write the result of that here also, minus 1 by root 2 minus j 1 by root 2. Now let us go through the calculations here. Here we have 6 into 1 into 1, that is equal to 6 plus. The connection is coming from 6 into 1 into 1, so that becomes 12. Now here 1 minus j plus, another connection is from 1 minus j, let us put the bracket as we should have multiple times, 1 minus j into this one, 1 by minus j into total factor 1 by root 2 minus j into 1 by root 2. Now we have to put the bracket, and You can evaluate the result of this calculation by using your scientific calculator, and the result you will be getting here is 1 minus j into 2.414. That will be the result what you will be getting. Just solve this equation using your scientific calculator, then it will be more convenient to you. Okay, now here we have 0 plus another signal is coming from 0 into this one, so now that will vanish. Okay, the result will be 0 here, and here we have 1.1 plus j into 1, that will be 1 plus j itself, plus another signal is coming from this side, 1 plus j into twiddle factor minus 1 by root 2 minus j 1 by root 2. Okay, again solve this equation by using your scientific calculator, and the result you will be getting is 1 minus j into 0.414. okay, 0.414. Just put it in your calculator, scientific calculator, then you will be getting this answer. Okay, right? And here we have a signal coming from this node 6 into 1, and another signal is coming from 6 into twiddle factor 1 into minus 1 is here. Okay, minus 1. Therefore this minus into minus is going to be minus into plus is going to be minus, therefore the result will be 0 here. Okay, and here we have a signal from 1 minus j, then another is plus 1 minus j into twiddle factor, that is 1 by root 2 minus j 1 by root 2 into minus 1 is there. Okay, into minus 1. Again put it in your calculator, and the result you will be getting is 1 plus j into 0.414. okay, now here we have a signal from this direction, that is 0 minus another is here also 0, so the answer will be 0. And finally here we have a signal from this line, that is 1 plus j, plus the signal is coming from this node, that is 1 plus j into twiddle factor. Twiddle factor is minus 1 by root 2 minus j 1 by root 2 into minus 1 is there. Again put it in your calculator and solve for the result, then the answer you will be getting is 1 plus j 2.414. okay, now the calculation is over, and here we have the output after the third stage of computation. That will be of course the output of our result, and here we have x of k, that will be the discrete Fourier transform of x of n, that should be of course in this order, that is 12 comma 1 minus j into 2.414 comma, next is 0 comma 1 minus j into 0.414, again 0, then 1 plus j 0.414 comma 0 comma 1 plus j 414. Here this will be the result of our